let's say it says here that part D now, it's saying D3, we have, let's do with DI first. Find a point where the function appears to be differentiable. So differentiable, we can say from -3 less than or equal to x, but less than -2. Okay, we are not going to include -2. And then we can start at -2 without including it. We go all the way to this next point, which is 2. We don't include 2 as well. Then, and we can now start at 2 without including it. And we go all the way. So you can say and, starting at 2, not including it. Then we go all the way to 3, but including it. So here are the intervals. Okay, so they cover those points. Why? They say, we can give the reason why. You can say function is continuous. You can put in bracket to say no holes, jumps, or vertical asymptotes, at these points. And also you can say and function is differentiable. And function is differentiable. Why? No cusps or sharp points at these points. Okay, so here now we do part 2. So you see here where they're saying differentiable, actually you should read it as continuous and differentiable, because the only way it can be differentiable is when it is also continuous. So first point is, please find when it's continuous and differentiable. So you have to prove that yes, it is continuous and it is also differentiable, because it can never be differentiable without being continuous. You understand? So yes, once you see them saying differentiable, know that automatically it also means it's continuous. So check if it's continuous, then check if it is differentiable. Okay, if it is not continuous, there is no way it is differentiable at that point. You get it? Because there's a jump or something is missing, there's no way you can differentiate like we saw here. You cannot say this is differentiable at this point. No, even though there is no cusp, we can't say there is a cusp or a sharp point. No, but it is not continuous, so therefore that will also lead it to not being differentiable. Okay, these cusps make it not differentiable, but also these jumps as well. All right, so now part 2, continuous but not differentiable. How does something become continuous but not differentiable? We choose the whole interval, so it is -3 less than or equal to s less than or equal to 3. Okay. Oh no, we want points where it is continuous but not differentiable. So we want here where there are points, and this is x equal to -2 and x equal to +2. These are the 2 points where it is continuous but not differentiable. Okay. And what do we say about this? We can say that function is continuous. We can show that function is continuous because there are no jumps or whatever. We are now getting used to these words. Function is continuous at these points. At these points, you can say that there are no jumps. Put in brackets, you can say there are no jumps, holes, or vertical asymptotes. And then you can say also now, and you can also say now, and function is not, you can say but, I guess, but function is not differentiable. You know why? Because there are some cusps, but function is not differentiable. Why? There are cusps at x equal to 2, at x equal to -2, and x equal to 2. Here we put it. So function is continuous, but function is not differentiable at this point. So we have found it. Now let's do part 3. They said it is not continuous and it is not differentiable. Do we have such a point? No. Okay, you can say no such points. Okay, why? Because when we look at the domain, you can now say that. Why do we have no such points? Because you can say function or y equal to f of x. Or we can say function, or let's just say y equal to f of x. Y equal to f of x is continuous throughout the whole domain, D. Okay, the whole domain D, which is from -3 up to 3. So why it is continuous throughout the whole domain, which is D, from -3 up to 3. Okay, why? There is no hole, jump, or vertical asymptote. So this just means there is no point where you find it being not continuous and not differentiable. Okay, because we've just proved that it is continuous everywhere, so no such point will ever be found where it is not continuous and also not differentiable. Okay, because we have already felt the continuity, so we don't even try to check the differentiable. This is done. Now we can go to question 5. Well done. All right, we'll continue in question 5. Goodbye for now.